So here I can go step by step such that you can understand what I'm trying to say. First of all, here I have considered x from point 2 to 1 and y equal to x minus 0.2 whole square, and just have a look at plot of this x comma y. If I just ask MATLAB to plot this, it will create a plot like this. This is too much disturbing. I cannot close this particular window. I don't know how to drive this one.
I think Professor Banerjee has some problem in his machine. He will connect soon.
Sorry, I got disconnected one second.
Yes, it is all right.
This is a problem for
Yes,
this MATLAB. Sometimes it is getting hanged, and that is the main problem. Okay. So what I tried to show you that this is the plot command, and this is just the curve. That means I have just plotted y against x. Now, as per your question, Muhammad Aram Amin.
Amin, if you have any question, you can put it in chat box. Please, sir, carry on.
Okay. So now what I'm going to show you how I can fill this particular area. So in order to fill this particular area, what I need coordinate of this point, then connect with this point, and then connect with this point. So for that purpose, what I can do, I can create a vector capital X, which consists with these points, that means X as these points, additionally 1 and 0, and accordingly capital Y as Y00. So that means apart from this curve X and Y, I am incorporating the point 10 and 00, this one. Or alternatively, you can think about as I am considering up to say point 2. So instead of that one, you can ultimately consider point 2 also, and then use this particular command, that is fill X comma Y comma R. If you do that, then you can get a plot like this. So that means this range is now filled up with red color. So suppose this is your bifurcation curve and you are intended to fill up this portion. Secondly, what you can do, you can consider one more curve, that is Y1. For the time being, I can just, this MATLAB is always creating some problem.
Sir, please close some of the applications from Mac. Then I think it will have better performance. Please wait some time. I think Professor Banerjee will join very soon.
Sorry for repeated interruption.
Yes, it's all right, sir. Please
Yeah.
carry on.
Let me switch off my video. Maybe it is putting
It's
too much
okay.
pressure on
Yes,
this thing.
it's okay.
Could you please allow me to share my screen?
Yes, sure, sure, sir. Yes, sir. Please share your screen.
Okay. So what I have talked about that if you run this command, then it will create a field area like this. Now you just comment this plot one, then comment this field command also, and now introduce one more curve. That means y1 equal to 2 into this, such that you can have a look at this plot. That means this is your one curve and this is your another curve. Now I'm going to show you that how you can actually fill up this region that is below this blue curve and region above this red curve. But for this part, what you need to choose, apart from this curve, that is it is ending at this point, you need to define this point, that is say 1.4 or 1.5, then 0, 1.5, and then 0, 0. So that means you have to define the boundary of the domain as a curve. And that I have done here. Now I have defined here x1. x1 is equal to this. Now I can make it comment, and then I can define another one, that is y1 equal to these things. And finally, I can ask MATLAB to plot this entire thing, that is two different region filled with two different colors, and in between there is a hold on command. So you can see x1 consists with x, then three more values of x, 1, 0, 0, and corresponding values of y1 are 1.5, 1.50. So just try to understand what I'm plotting here. Apart from x and y1, I'm joining the point 1, 1.5, then 0, 1.5, and then 0, 0. If I combine these two and ask MATLAB to plot, then it will create this kind of picture. And now if you want to plot this particular region with a different color, so that means first you define this curve, then join with this point, and this part is quite interesting. You need to define it in a reversed way. That is the thing. That is the clue. Or you can keep it as it is. So I hope I am able to answer your question. And this is very simple thing, but my suggestion is that better to go with these curves only and mark the region as R1, R2, R3, because sometimes it may happen that one curve may share the domain with two different curves. Then this color will lead you some sort of confusing things if you are unable to find out equation of all the curves explicitly. Okay, so this part is done. Now I can move to some other things, what I am intended to talk about. Okay, so here I can show you one particular command for this numerical simulation. So here I have two different function I have already defined. One is pre, that means x, y, beta, and alpha. And just if you look at the reaction kinetics, then you can understand this is the modified Rosenwick-McArthur model by including alley effect. That is x into x minus beta, 1 minus x, and then minus xy by x plus alpha. This is the growth equation for predator. And now in this particular command simulation rk4.m, I'll send you this M file. So do not get scared. So what I have done here, just follow my step-by-step instruction. Up to this step, this is standard. Tick, you can remove it. It is just actually used to count how much time it is taking. So for that purpose, you need to use this tick, and at the end, you have to use this command top. So first of all, let me show you the outcome, and then I will explain what I have done here. If you ask MATLAB to run this command, then you can see the second picture that I have shown you for that model, it can be generated. Let me explain you what I have done. So first of all, I have defined the parameter values. So these are the parameter values: alpha 0.5, beta 0.2, delta 0.2, and gamma equal to 0.36. M stands for how many iteration I want. As I have discussed yesterday, I have defined here x, y, t. In this case, we are considering the phase portrait. So you can remove this t also. That is not at all required. And also from here, you can remove this part. And then I have created, defined these initial values, x equal to 1 and y equal to 0.001. So that means it is assumed to be, it is a point very close to the point 10. So just inside the domain. And then I have written this RK4 method code in order to have the simulation result for x, y. So for the time being, I can just, for example, I can make this particular part as a comment, and let me discuss about the outcome. So once you have this kind of comment ready, you ask MATLAB to perform the simulation, it will show you this picture. Now, what I have explained earlier, that for 0.36, trajectory will start from 10 and will converge to this point. But if we take some small values, say 0.34, so what will happen? Then you can see this will converge to the stable equilibrium. If you increase it a little bit, that is 0.345, you will see that still it is stable. But if you consider, say, 3.5, then you can see you have a small limit cycle. And then the gradual increase of this particular value of gamma from 0.35 and onwards, you can see that size of the limit cycle is slowly increasing. That means 0.351, it is increased, size of the limit cycle increased. Then 352, it is this much, and so on. If you just keep on considering some higher values, at the every time you can see size of the limit cycle is getting increased. And even for 354, you have further increase in the size of the limit cycle. And again, 355, you can see limit cycle, now it actually disappeared. And once you can see this kind of drastic change, what we observed here, that 0.354, you have this limit cycle, and all of a sudden, this 355, it jumped to the point origin. And just try to understand that parameter gamma here manually we have changed drastically from 354 to 355. Practically, it is changing continuously. So if you can try to capture the continuation, then slowly you can capture where the heteroclinic orbit lies. And in order to capture the heteroclinic orbit, what I do in general, because you cannot find out any analytical approach, so just apply some bisection kind of method. What I'm trying to say, bisection kind of method means For example, first step, I can consider 0.35. There is a limit cycle, and then I can change it to 0.36. You can see it is gone. Then what you can choose a parameter value in between 3.5 and 0.36. So just consider 355. What you can see, still it is converging to this one. And then you can understand that your value is lying between 0.335 and 0.355, because 0.35 there is a limit cycle, 0.36 that went to origin. Here 0.355 it went to origin. So that means limit cycle is in between 0.35 and 0.355. So that is some sort of bisection method. Now by this time you already are familiar with the fact that 354 will give you limit cycle and 355 giving the extinction. So that means that heteroclinic cycle lies between 0.354 and 355. Either you can keep on increasing step by step, that is 0.3541, then 0.3542 in this way. Alternatively, you can keep on using the bisection method, or maybe reduction from both the side. Maybe I can change it to 3544. It is a large limit cycle. Now I can change it to 345. Again, it went there. So that means it lies between 3544 and 3545. So in order to do that, again, you can choose 3.441 and so on. And if you keep on proceeding like this, ultimately you will be able to arrive at a certain threshold at your level of desire. But what is most important at this stage, you can see that 0.36 will give you this structure. It is converging to 0, 0. Now, apart from this one, I can use the hold on command and choose M1 equal to 40,000. Not that much simulation is required. I'm constructing X1 with zeros at the first stage. And then the most important part, I'm going to construct the stable manifold of the axial equilibrium point 0.2, 0. And just follow my argument carefully. Here I have chosen X1 that is equal to 0.200001. So that is a small perturbation from 0.2. So what is the equilibrium? Equilibrium is 0.2. Then X is your 0.2. X0 is this one. So that means the difference X minus X0 is this much. And now using the equation of stable manifold, that means using the slope of the eigenvector associated with the negative eigenvalue of the Jacobian matrix, as I have demonstrated is in my previous lecture. You can recall first component of the eigenvector was 1 and second component was 1.26 minus gamma. So that means that W2 by W1 is not required because W1 is 1 itself. Using that equation, I have determined the coordinate of y. Follow my argument. Y minus y1. This is my y. This is my y1. That is 0. Plus m. M is W2 by W1. W1 is equal to 1. So only W2 is there. Times x minus x0. What is x? X is this much. What is x0? 0.2. So you have your initial point. And then what I need to do, I just need to write down the RK4 method, keep in mind with backward integration. So that means instead of changing dt to minus, I can just consider minus here. Instead of adding, I can subtract here. And once this is done, then I can ask MATLAB to plot this x1, y1 and see what is going to happen. If you look at this plot, you can see that the stable manifold is coming out from unstable equilibrium and this is going to this position. Now, what is the benefit of using this kind of code? Benefit of using this kind of code is that now you can just play with your gamma without making any other change. Just for example, this is for your gamma 0.36. If I make it 0.35, quickly it will give you the another picture. So here is a problem. As we are considering backward integration, so this trajectory is going to diverge at some point, and that's why this error line is coming into the picture. In order to remove this error, we have to cleverly choose the desired number of iterates to plot, and that's why if you consider only first 15,000 iterates, that will be enough, and then you will get this picture. Now you can see it is not complete, so you can increase a little bit more number of iterates to see how it looks like. Instead of 15,000, now you can choose 17,000. Again it went out, so that means it lies somewhere in between. And why this is happening? This is happening only for the reason because we are not taking care of the tolerance level and accuracy of the numerical code. That's why when X and Y, they are keep on increasing, so they can take some large value, and at that level, due to wrong choice of the time state, there is a change from one domain to other domain, and drastically it will move away from the desired direction. Because with the increase, we are not changing delta t gradually, so that's why we are having such kind of problem. And in this way, depending upon the fact whether it is a stable manifold coming from infinity or stable manifold coming from an equilibrium point, accordingly you need to make some alteration at this particular position in order to have the clear-cut idea. So this part is not required. This was actually part of the comment for some other thing, but finally I can show you with this one. You can have this structure. If you wish, you can have few more iterates, maybe 6,200, and here also 6,200. This is complete. But just for your clear-cut understanding, I want to make one more comment here, that instead of considering this diagram, that means you can just remove this axis comment. If you remove this axis comment, what will happen? You can see that how the trajectory moves beyond 1. And you just try to understand that if I consider iterates up to 16,000, it is showing a growth up to 1. It is probably you can see there is a gap. It is still did not reach the value x equal to 1. So 16,000 iterates gives the system movement from this point to this point. But now if you add only 200 iterates, just 200 iterate here, then you look at the plot, it already arrived up to 3. So there is a sudden rapid growth. And once you can see this kind of rapid growth, what is required, you need to actually reduce the step size. If you are efficiently write your code, then you can change your step size, that means time stepping, depending upon the stiffness of the problem. Otherwise, because within this limited time period, I can not show you each and everything in detail. So that's why I'm just showing you this plot, that how it can be done. But what is the advantage of this particular code? Advantage of this particular code is that once this part is ready, now you can play with your gamma. So here gamma is 3.5. Just slowly increase your gamma value, 0.351. Then you can see that, okay, still there is a limit cycle and this stable manifold lies above this curve, and this is clear. Now you change it to 0.352. Again, you can see still it is above, but you can see that that much of iterate cannot complete the desired level of the curve here. So if you want to have this curve up to this point, then you have to change the number of iterate at this particular stage. But the point is that our main goal, that is there is an exchange of the manifold, that means stable one goes below the other one, that can be easily captured here. So 0.352, then 0.353, you can see this kind of plot, and you can see that these two manifolds are coming closer and closer to each other. And then again, if you consider 0.354 instead of 353, you can see they are more or less close to each other. And this will give you some clue that at some value, they of course coincide with each other if there is no any other kind of catastrophic shift in the system due to presence of some attractor. But for this model, there is no other equilibrium point. There is no possible of any further bifurcation except the heteroclinic bifurcation. And now if you change it to 0.355, and you can see that this trajectory is now moved from this position to origin, and it is somewhere in between. Now, in order to understand its final destination, what you need to do, now you need to remove this restriction. That means instead of plotting first couple of iterates, instead of that, you need to plot the entire curve to see ultimately where it will converge through backward integration. And you can see it is ultimately converging to this one. As we have obtained this trajectory through negative integration, so that means if you start from a point here, it will converge to this. Now at this point, I will give you an important clue. Question is why I am interested for negative integration of this point. Idea is that if you want to construct this trajectory from a nearby point of the equilibrium, you don't know from which point, if you start, it will converge to this point. There is only one trajectory. There is not more than one trajectory. So better you try to construct the stable manifold through negative integration, and ultimately it will converge to this particular equilibrium point. And as I told you earlier, that if you do these things with the appropriate code, then you can find the heteroclinic bifurcation. So these are the some codes with which I have constructed those figures, and I can show you. Just if you use this one, that is exact value of gamma 0.355, this one, so you can find the structure of the heteroclinic orbit. And again, the two trajectories are shown here, so that's why it is creating such kind of noise. But for the time being, if you just remove this particular part, that means if you make it comment, then you can see the exact heteroclinic orbit here. This is the main idea. But what I want to show you out of these things, let me stop all the plot comments. I am not plotting anything here. So this plot comment is now commented. This plot comment is also commented. Hold on is on hold. I just perform the numerical simulation. Okay, so nothing is there, but screen is appearing because axis comment is given here. Okay, now I can go to the command window, and just keep in mind that I have one trajectory with XY, another trajectory with X1, Y1. And now I will show you first couple of iterates how they looks like. So let me plot X, say 1:1000 with Y 1:1000 with say blue color as I have done earlier, and with the line width 2. If you use this command, then you can find. So just try to understand, you are getting only a small portion because I have started from here, and then growth is very slow. Then I can increase the number of iterates just to have, say, 2000 iterates, just to show you how it is actually evolving. Then you can see little bit of more growth. But ultimately, if I go for, say, 5000 iterates, that is I'm going to plot 5,000 iterates. So still it is in a growing mode. And why this is there is a slow growth? Because it is on the unstable manifold, and the growth rate is quite slow while the point is chosen very close to the equilibrium point. But instead of 5,000 iteration, if I consider say 15,000 iteration, then you can see it is still in an increasing mode. But ultimately, if you consider few more iterates, maybe 25,000, and then you can see the ultimately trajectory is getting constructed, and it seems to you that is it is getting started from 1, 0. But if you have a close look, as I have shown you earlier, that is not exactly the point 1, 0, but pretty close to the point 1, 0. And finally, if I keep on increasing the number of iterates, that means say 35,000 iterate to see its plot, now you can see some sort of bending. And in this way, you have to understand that how many iterates is required to be plotted in order to see the clear-cut heteroclinic orbit. So when I just change from 35,000 to 55,000, you can see it gives you the complete trajectory. But who are very much clever, they can ask me the question that I have mentioned, that this trajectory heteroclinic orbit consists with this branch joining this one and this point. Another one is following the x-axis, but x-axis means your y component is 0, and once y component is 0, it should not come out. The answer is that this is a numerical approximation, and if you have a close look at this particular point, then you can see there is some sort of gap between the trajectory and the actual point, that is 0.2, 0. So just from visual precision, we are considering this as a heteroclinic orbit. But now, as I can show you this zoom version, you can clearly understand, although earlier it seems like that was a heteroclinic orbit, but that is not at all a heteroclinic orbit. Rather, it is a close approximation. But for your presentation purpose, this much is enough, because now you can ask me the question, why this much is enough? Again, I need to return back to the original code, and I can show you, if you look at the entire plot of XY, it seems to you this is a heteroclinic orbit. But if you change the parameter value a little bit, say for example, in case of 588, if I make it just 6 instead of 588, if I just consider this as a 6, then you can see this disappeared. So trajectory starting from here, coming very close to 0.2, and then it is approaching towards 0, 0. So what we can say, that this is some sort of correct measure of the heteroclinic bifurcation threshold up to this many decimal place. So the point is that instead of changing this 588, even you can see that it is not coming back to this position. So what I have done, I have just checked that in case of 588, it is giving you a cyclic kind of structure, seems to be heteroclinic orbit. But if you consider it as 8, 9, just instead of 8, 8, 8, 9, you can see it is going that particular way. So in order to have the heteroclinic orbit more close to the point 0.2, 0, so then you need to consider few more decimal place. So that much of accuracy is required. And finally, just for your quick recapitulation, if you ask me the question how I have obtained this value, I have already explained in the previous program, that is 0.35, then 0.354, then 3544, and so on. In this way, I have collected all the values and ultimately got that kind of picture. So that is one thing. Secondly, now I can show you the code for the other comment, that is a heteroclinic orbit, and I'll send you all these codes. So this is the complete code for the phase portrait that I have shown you. And in this case, just for because as you have seen a couple of times it got disturbed, so that's why I'm not performing any sophisticated numerical simulation, but just to have some sort of acceptable simulation, what I have done, that cleverly I have chosen dt equal to 0.1, and then I have applied Euler method. Keep in mind, this is just for demonstration and illustrative purpose. For appropriate numerical simulation, you have to convert this code into, your RK4 method. You have to modify this code. And if you go through this code afterwards, you can see that how many different trajectories I have constructed. This is x1, y1. This is one simulation. Then I have x2, y2. Then I have x3, y3, x4, y4, and so on, in order to have the complete structure. And now with a very simple tool, I can explain, or I can actually give you the clear-cut idea that how all those trajectories can be identified separately one by one. So with this particular picture, now I go to the properties of the picture. It is opening. So graphic tool has been opened, and now you can see this many curves are plotted here. So I can off them one by one, and you can see each of the curve is getting disappeared. All these trajectories are disappeared. So in this way, I have actually prepared those files for your presentation, and just look at the simulation result. So this one corresponds to manifold which is coming out from 1, 0 and converging to the point 0, 0. So this is that particular trajectory. This one is the curve which is starting very close to the equilibrium point, and through numerical integration in backward time, it ultimately converges to the limit cycle. So this I have used to plot a sample trajectory inside unstable limit cycle. Then if you look at this one, so this is the trajectory starting from here converging to the origin. This one is the stable manifold of this equilibrium, because it is starting from unstable limit cycle and converging to this one. Once I will send you the code, you can go through it and you can find I have obtained this particular trajectory by negative integration from this point, and slope of the line is again calculated by hand, or you can do it in Maple, that what is the direction of the eigenvector. Once you have the direction of the eigenvector, from where you can find out the slope of this line, and accordingly you choose a point very close to this equilibrium point but on the stable manifold, and do the negative time integration, you will get this particular trajectory. Now this one will give you curve joining these 2 points. Again, if you remove this one, introduce this one, then you can see this is starting from here and converging to this one. So this is another branch. This one is joining these 2 points, and finally this will give you few more trajectories. This one, this is another trajectory, and this is another trajectory. So all the time you can see it is starting from somewhere here and then converging to origin. So this is also starting from here. But if you now incorporate the other trajectories, that means you can check that one of them, this initial point, lies below this particular manifold, and this initial point lies above this particular manifold. So in the previous lecture, you were asking something about how to choose the parameter. And here, of course, you may raise the question how to choose the initial point. That is completely depends upon the position of the manifold, and accordingly, you have to choose the initial point. And ultimately, again, I resume back all the trajectories, and then you can see this is the complete phase portrait. So I think I have, okay, one more thing I should show you, that is the homoclinic bifurcation thing, and that I have created with, No. Okay, somehow I missed that particular code here. Before this one. Sorry, I actually missed that particular code. And this is some sort of code I have used for this stable limit cycle that I have shown you yesterday's lecture. Okay, now I must stop here. And if you have any query or something else, I would love to answer any questions.
Thank you very much, sir, for your very nice interactive lecture. So now this is question answer time. So if you have any question or comments, please put your question in the chat box. Is there any question or comments? Sir, I just have one query. So
Yeah.
when we have a higher dimensional system, 3-dimensional or more than that, in that case, in order to understand the bifurcation diagram, then what is the most convenient way? I am asking, should we take the projection of the original diagram in 2-parameter plane or something like that?
Precise answer I can give you that because you cannot go beyond 3 dimension, right? So the main thing is that you have to choose your that is bifurcation parameter appropriately, and at least 2 dimension and at most 3 dimensional bifurcation diagram that you can construct. Check. Okay, so just for the participants, again, I'm going back to this particular comment. Somehow I'm able to manage, and this is corresponds to this homoclinic bifurcation. So with this one, I have actually plotted these 3 limit cycle. So what you can consider here that this code, so one part that is x2, y2 for delta equal to 0.83. Then this part that is x3, y3 corresponds to delta 0.4. And finally, for delta equal to 0.846, I have obtained this one. And then I have used these 3 commands to have these 3 cycles. So one of them is blue one, second one is magenta colored one, and third one is seems to be this homoclinic bifurcation. I think there is some question.
Yes, there are some questions. So I think backward bifurcation you have already explained in the last lecture. How to draw different stable and unstable region.
It is not required to draw, because once you have these manifolds, as I have shown you that manifolds earlier. So just for example, if I consider this stable limit cycle thing, and the fact that this particular card, if you look at this one, that is the plot of this card. So this is the separatrix between basin of attraction of origin and this stable limit cycle. So for a quick demonstration, again, I can do the same thing. I can remove the curves one by one, and then you can see that there is a clear-cut demarcation between these two. And so this is the entire region which is basin of attraction for this equilibrium, and rest of the part is the basin of attraction for 0, 0. Because if I introduce this trajectory, you can see it is converging to 0, 0. But if I introduce this one, it is also converging to 0, 0. But if I introduce this one, So it is actually the stable limit cycle. Instead of this one, if I plot these things, so then it is starting very close to the equilibrium point and ultimately converging to the stable limit cycle. So this is the simplest way. And now you can ask me the question, okay, how I have obtained this particular curve. So for that, it is corresponds to ratio dependent model, and you need to perform the explicit analysis for the origin theoretically in order to identify this manifold. Alternatively, what you can do, you can choose some initial point along this vertical line and then try to find out the point of demarcation above which trajectory will be converging to this 0, 0 equilibrium point, below which you have the trajectory converging to the stable limit cycle. And then if you zoom out this particular position, or rather, sorry, zoom in this particular region to identify the point from where trajectory is starting, which is the separatrix between two basins of attractions.
So thank you. Next question is, to run this in MATLAB, any other software needed? I think
no.
And next question is, we know that a parameter is very important part of the numerical analysis and draw graph. So the question is how to find out or measure the parameters from real data in mathematical model or by any method with the help of MATLAB.
Then you have to apply simply estimation of parameter. If you have the data from data, you have to estimate the parameters. That is the straightforward thing. And there is several books that how to estimate the parameters from the data. And frankly speaking, I am not expert in that particular area. That most of the time I take help from some of my collaborators who are actually say field biologists, or I know a couple of person in India also. They are very good in that. And there are several different methods that can be applied to estimate parameter from the real data. Next question is that different papers we have seen researchers used hypothetical data, but for real data of any ecosystem, how can define a valid model? Okay, this is a very good question. Couple of researchers have started their work in this direction. Depending upon the data, it is quite difficult to assure whatever model we are considering that is a valid model, because instead of giving a clear-cut answer to this question, rather I would love to pose one question, and that is very much challenging, and very few people are able to understand the essence of that particular thing. And that is nothing but, if you have a data, how to decide whether we need to consider a ordinary differential equation model or partial differential equation model or delay differential equation model or even stochastic differential equation model or any combination of these. So main thing is that once you have data, you have to know how the data is collected, whether the further refinement is required or not, and also based upon the collected data, what kind of interference, that is how we can infer or interpret those data, depending upon your interpretation and also your goal, that how to utilize this data for further research, that will give you the guideline how to construct the model. But of course, you can ask me the question, okay, in case of a resource consumer model, I have chosen Holling type 2 function, then why it is not Holling type 3? Then you need to go back to the biology. That means mechanistic derivation of those functional response to understand which kind of species you are having in your hand. For them, you have obtained the data. So depending upon the nature of the interaction, that means interaction within aquatic environment, interaction within land. So that means you can think about small fishes are captured by large fishes. That is a type of prey predator model. Sometimes polar bear during summertime, they catch the fishes from the aquatic environment. So that means predator stays in the land. and they are hunting, or they are actually catching the prey from the aquatic environment. So interaction between fish and the interaction between polar bear and fish, that should be completely different, and depending upon that you have to choose appropriate function response.
Yes, sir. I think.
Okay, definitely I'll share my MATLAB codes with the organizers such that they can send to all of them. And another question for initial starting point, is it always by trial and error by considering the stable and unstable regions? No. Probably you did not got my point. I am not talking about trial and error method, because here the trial and error method I have used, or I have just emphasized, because the model is a ratio dependent model. In case of this heteroclinic orbit, you can clearly understand that what kind of simulation is required. So that means if I have the parameter value that is little bit less to this one, so that means let me consider 0.34, and here I again go back to this particular range to plot here, and then there is no trial and error. Rather, if I just consider this much of iterates, then entire domain lying between this stable manifold is the basin of attraction of this particular equilibrium point. There is no trial and error, because in earlier case what I have said, because in case of origin the behavior is quite complicated, and that's why it is difficult to find out the equation of the separatrix from the subspaces of the origin. There is no subspaces at all, because at this point the Jacobian is not unique and you cannot identify the stable and unstable subspaces, and that's why we need to take help of some trial and error method. So in this case, instead of considering say beta equal to that is gamma equal to 0.34, if we consider 0.33, you just change the parameter, you will have this picture. Of course, due to number of iterates, you are having this line, but actually the area below this particular curve is the stable region of this equilibrium point. No trial and error is required.
So, sir, the next question is the logistic map a bifurcation diagram?
Not at all. Logistic map is a single variable difference equation. How logistic map can be a bifurcation diagram for predictive?
Okay, is there any more questions? I think no. Once again, I'd like to thank Professor Dr. Maloy Banerjee for his wonderful lecture.
Just 1 minute. There is one more question. RK or Euler, which one give effective solution for this model? As I have said, probably you did not catch my point. Just for time constraint and in order to avoid the computer should not get hanged, I have used Euler method, but all the time I prefer, rather I suggest to use RK4 method with effectively choice of delta t. And last question from Onal Chatterjee, that is why use backward integration? Because we are actually constructing the stable manifold starting from the destination. So that's why negative time integration or backward integration is required.
Any more questions or comments from the participants? I think no. Once again, I'd like to thank Professor Dr. Maloy Banerjee for his wonderful lectures today. So before concluding, of course, our president will conclude the session. But before that, I'd like to say a few words. As far as my experience, so I'm working on auto from my PhD study. Still, I am working with auto, but the analysis that was presented by Professor Molloy Banerjee yesterday and today, I think from the acceptability viewpoint, the acceptability is higher rather than auto or MathCont or something like that, because the mathematical analysis is involved in such a bifurcation analysis. That's why acceptability is quite good rather than the bifurcation analysis using auto or MathCont or any other packages. That's why I recommend the young researchers, particularly our students, to learn such analysis and to be a master of that analysis. If you are interested to do research in mathematical biology, that would really be helpful for us. Not only for young researchers, for me also, I am personally benefited for the yesterday lectures and today's lecture also. That is my feeling. Just I would like to share with you all. And now I'd like to request Honorable President of Bangladesh Society for Mathematical Biology.
Excuse me,
Yes.
Professor Kobi, just to interrupt you.
Yes.
I have one take-home message to all the students. What I have understood, most of the time students are trying to learn the subject by reading the paper. My suggestion is, if you are interested to read some paper to learn the subject, then please consider the papers by authentic persons who are established. A quick list of such authors are, say, Philip Moyni, Alan Hastings, Simon Levin, Mark Lewis, etc., etc. And otherwise, just try to understand the details from standard book. You can ask me the question, what are the standard books? There are many, but at the end, I can mention one more thing. That was very excellent suggestion from my supervisor, who always told me, whatever book you are having in your hand, you go through it, try to understand. If you can identify there is a mistake, and if it is a mistake, it means you learn the subject. So without just going through, just to complete your work or PhD research work or a paper, try to understand what is written here and then try to interpret as per your own. If you can mention at the end that, okay, my lecture is interesting, I am able to convey some message, or you are happy, that is only for the reason all the time I try to present my understanding rather than materials taken from some book and from my experience.
Thank you, sir. Thank you very much. Now I'd like to request the president of BSMB,
Professor Dr. Roman Ravi.
Yes, sir.
I think we have our some executive committee member or our board members just say some few words. Feelings.
Yes, sir.
About,
Yes, sir. Okay, so in that case, I'd like to request Professor Dr. Chandranath Poddar sir to say a few words regarding this today's workshop. Sir, please unmute your audio.
Thank you very much, Dr. Mohammad Humayun Kabir, Honorable Secretary of Bangladesh Society for Mathematical Biology, Honorable President, Professor Dr. M.D. Haidar Ali Bishwas, and our the renowned professor in this area, Professor Dr. Molloy Banerjee. On behalf of the society and on behalf of me, I must congratulate Professor Dr. Molloy Banerjee for your excellent talk, and also as well as the graphical interpretations using the math lab you showed yesterday and today. That was really excellent, and especially for our young researchers and our graduate students. So we are really grateful to you from our society that you have gave your very important time to our dear students. So once again, I thank you to all the participants, because the Society for Mathematical Biology is organizing, say, like every 3-4 months, this kind of special program, just because of our students and young researchers. So again, I thank you, our Professor Dr. Mola Banerjee, and thank you to all the participants. So thank you all. Thank you very much.
Thank you, sir. Thank you very much. Now, I'd like to request Professor Dr. Usman Guni, Vice President of BSMB. So, sir, are you here? Professor Dr. Usman Guni, sir, can you hear me? I think he's not here. Next, I'd like to request Professor Dr. Muhammad Amanullah to say a few words regarding the training workshop.
Thank you. So this workshop will be organized by our society, this Bangladesh Society for Mathematical Biology, and our honorable resource person, Professor Dr. Mola Banerjee, give a very influential and very authentic lectures, especially the simulations, because I really use the Fortran, and sometimes I use the MATLAB to draw the graph. But here, Professor Banerjee also use this MATLAB. So especially, I'm very much happy to his discussion. Firstly, every first session in both day, yesterday and today, they discuss the analytical, that is the mathematical process, and we describe this one. And I think, especially for me also, I'm very much benefited from these lectures, and I'm very much interested to this topic also, and hope that in future we also arrange such kind of very nice and interactive programs, and our young researchers, especially our students, also benefited from such kind of lectures. And we're very grateful to our society, especially our audience who actually who are actually success our this kind of workshops. So I'm very glad to our honorable resource person, Professor Mona Banerjee, and our society. Okay, thanks. That's it.
Thank you very much, sir. So I think Professor Usman Guni sir is not available. So in that case, I'd like to request the Honorable President, Professor Haider Ali বিশ্বাস, to say something and conclude.
Professor Pavel Shahriar is here.
Yeah, oh, sorry. Professor Pavel Shahriar is here. Professor Pavel Shahriar, sir, can you hear me? I'd like to request Professor Pavel Shahriar to say a few words.
Am I clear?
Yes, yes. You are
listening. Okay, so thank you very much to the organizers first, in particular to the chairman of the society, as well as to the secretary, executive committee members. Almost all of us were active today as well as previous day. So I am personally thankful to our president and secretary for arranging such a wonderful workshop. It was we thought it was not possible virtually at some stage because we are passing through COVID and other things, but it is clear that this is possible, and we are successful for this event, I believe. And the benefit which generate through these courses delivered by the eminent speaker, Professor Mola Banerjee, we understood almost everything. But yeah, if you are not going through and doing the research by yourself, you cannot claim that you understood everything. Once you go through all the things, all the topic, and once you came to know, okay, it is what like this, then that will be benefited for our future students and the running students. My comment for the audience, in particular for the students, the way Professor Malay Banerjee showed us the graphs, in particular the bifurcation diagrams, it seems very easy, but consider yourself that you are not an expert. So it may took a week even to get a line from that graph. So for yourself, since you are not expert in this field, you have to go through trial and error basis. But that will definitely not the case for Professor Malay Banerjee or some other professors. I'm seeing Uttam Ghosh, Murthy, Dr. Murthy, and some of our researchers who are doing this bifurcation analysis and other things. So keep patience. When you go through all this stuff, definitely you occur some error.
It's 6:30.
Definitely there will be some error, and you have to making mistakes is very easy. It's not that is okay, completely okay, but you have to understand the thing where the mistakes are commencing by you. That is very important. Once you came to know the okay, my mistake is here, I am stucking here, I am not getting that point clearly. Once you came to know that point, then you can execute from that barrier. Otherwise, that will not functional for you. Sorry for taking a bit more time, and thanks to the audience, thanks to our executive committee as well as president and secretary. Thank you very much to give me the floor.
Okay, thank you very much, sir. Now I'd like to request Professor Dr. Mohammad Usman Ghani to say a few words.
Thank you very much, Dr. Humayun Kabir. And first of all, I would like to thanks to the organizer of this training workshop, BSMB, Bangladesh Society for Mathematical Biology, and our Honorable President and Secretary did lots of effort to make this workshop successful, and we believe that our today's workshop really successful because we see lots of participants in this workshop. It was above like 120 participants was there sometimes. And I am really very happy to see such kind of training workshop in our country we can organize. Because of this pandemic, we take such initiative to organize virtually these types of training workshop. But if the time is not like the COVID time is not passing, then we probably will not think to arrange such types of workshop. So this is the benefit of pandemic, I think. We last month we organized a very successful conference. We listened 11 eminent speakers who was the prominent professor in this field of study. But actually, without this pandemic, it probably will not possible us to listen their talk, because we cannot arrange such types of conference. I mean, without virtual, we cannot arrange these types of conference. In before, we invite several professors, try to invite several professors from abroad, but it was not actually finally possible to get themselves in our country. But let me conclude my talk. I personally very thankful to Professor Malloy Banerjee to give his valuable time for our students. He's a very busy person, we all know, but arranging such time for all of us, it was very great. And the way he showed the bifurcation diagram was really fantastic, and we found a clear-cut idea from those from the model, from those discussions. But we know there are several packages to draw bifurcation diagram, auto, or for the PDE case, OFTrain, and MathCon, and so on. But the way he showed us, it was really very nice, and we found clear-cut understanding from his lecture. So thank you very much, Professor Malloy Banerjee, and we hope that in future we can also arrange such types of workshop for other models if possible. And I personally was very serious to listen his talk, and our students will get lots of benefit from his talk. And students who is just trying to start their work in dynamical system, I think they can start from here. They can start from this workshop. They will get lots of benefit. So I hope the students and young researchers a great success in their future, and they will start their work from here. And thank you all again. Thank you very much, our secretary and president, to organize such types of nice workshop again. Thank you.
Thank you, sir, for your valuable comments. So now I'd like to just take the feeling of one of the participants. So from the participants, would you like to say something? Particularly from students.
You can share your feelings from.
You can freely share your feelings or
from
observations.
Bangladesh, from outside Bangladesh, from other countries as well.
Anybody wants to share your feeling or observation regarding this training workshop?
Many are sharing their observation in the chat box.
Yes, chat box they have already shared.
Okay, I think we can make a screenshot for the memory of about this program with our honorable speaker as well as all the participants. So we request for the participants to open the video just to take the picture.
Please turn on your camera so that we can take a picture, and that is a memory of event. So I'd like to request to turn on your camera.
Turn on camera, please.
I'm on.
Yes, sir.
Dr. Usman Ghani, Professor Usman Ghani.
Professor Usman Ghani, sir.
There are many other states.
Please, what, please?
You need to make up in.
Assalamu alaikum wa rahmatullah.
Please be online.
রেডি ছিলাম না তো, আপনারা যে এরকম করবেন সেটা তো বুঝতে পারিনি।
Mathematicians are always ready.
এখনো রেডি না।
Okay, let's take.
Let's take a picture, all the three pages.
Yes, sir, I have taken.
Okay.
Thank you very much. So now I'd like to request our Honorable President to conclude today's training workshop. Sir, please.
Thank you everybody again, and thanks all the participants from home and abroad. Actually, this program, when we discussed in our executive committee, so it was actually a trial version because due to the pandemic, we are not taking any initiative to organize such type of training workshop physically. So we are thinking to organize physically. Still, we are running 2 years since our establishment of the society, but still the pandemic is running. So we just made a trial version for our students, especially our young students, master's students, MPhil, PhD students, as well as our young colleagues, because I believe many of our young colleagues have been benefited from this talk. So it was actually my proposal and as a trial version, and Professor Malay Banerjee also discussed yesterday, because it is very difficult to discuss, to show all the details from a remote from the remote space. So, so I believe actually, though it is in the remote space, but we hope we enjoyed, our young researchers or students have enjoyed. They have learned a lot from this talk, especially both analytical and numerical. It is very important for the analyzing for the dynamical model. And what Professor Malay Banerjee said, I also agree with him, because we mainly use different type of solver or software, but there are many functions, there are many problems, especially for the non-smooth function. When the functions are non-smooth, so there are different cases, the function may not be continuous in different points. So in that case, there are some limitations also in the solver. So I request all the students who are working now, who are starting their life journey, or our young colleagues, always try to make the real code, writing the codes and studying this analytical analysis first, and what is going on to see, to validate this by using numerically, so using the code, MATLAB or some other different computational tools. So this is our first attempt, and I hope we have successfully finished. And all our participants, I request to fill up your feedback form, how you feel about our program, our event, so that we can make other events for the students, for our researchers, for our colleagues. So thank you everybody for this today, for attending to this workshop. Though it is 2 and 2, like 4 lectures workshop, but still we made a long time for this, both theoretical and numerical purpose. So thank you, Professor Banerjee, because when I asked him, he is like my friend. So when I asked him to propose some expert's name, he willingly agreed to do that. He told that, okay, I will be there. So I am very much happy. And on behalf of the Society for Mathematical Biology, we are grateful to you for giving your time for our students, for our colleagues, and for our young researchers. So we hope you will be always with us for our society, and hopefully after pandemic situation, we could meet together and we will arrange for a larger scale, especially for at least 5 days, more than 2, like 5 or 7 days physical workshop, and so many other programs. So we request all our participants here. There are many students here. They are not the member of the society. So I request all the students who have already completed your masters, or who completed your BSc, they can also be a member of the society. and who also completed the masters, they can apply for the life member for the society. So I request the students or all the participants or the researchers or scholars who are working in this area, you should be involved with the society, and you should show your talent. You should make a greater progress for the society of mathematical biology and connecting a national and international networking working in this area. So thank you everybody. Thanks for attending our this today's training workshop, and we hope we will meet in future in similar events like workshop, conference, or some other events. So by this time during pandemic, stay safe and stay healthy, and we hope the pandemic will run out soon, and we will get a better world soon. Thank you everybody. Thank you all.
Thank you, sir. Thank you very much. We are at the end of the program. So I'd like to notify the participants, particularly those who have registered and filled out the feedback form. And e-certificate will be issued within 1 or 2 weeks, and it will be sent to you email. Okay, on my personal behalf and on behalf of the society, I'd like to convey my sincere gratitude and thanks to the eminent speaker, Professor Dr. Maloy Banerjee, for his valuable time and to make this training workshop a successful one. Last but not least, I'd like to thank all the participants for joining this training workshop. Thank you very much and stay safe. And we'd like to end here, conclude here. Thank you. Thank you very much.
Amal bhai kichu bolbe naki? He raised his hand.